When we think about the basics of lighting, we need to first focus on lighting theory, the source of light. So when we have a source of light, it's measured in candela. The abbreviation is CD. So in this case, we have a source and then we have the beams of light, the flow of light, which is measured in lumens. So this is the visible light. And then we have the illuminance, which is measured in lux. The illuminance, the area which is reflected with a light source, so we can see that those elements or those objects in a clear manner. Let's understand the different types of artificial lighting, and we all know candle. But what happens next? So there is incandescent light. This is one of the most inefficient way of lighting in the modern day. Halogen light is a light source that's very similar to the incandescent light. It's kind of a cousin of the incandescent light because it uses the same principles. However, in this case, there is an extra layer of gas that's called halogen, and the name is taken from there. In order to bring more efficiency and increase the durability, but it still uses a lot of heat, and it's not as efficient as the next two bulbs, lighting sources we're going to discuss. The next one is CFL, so compact fluorescent light. This is a system that most offices use, and the next one will be LED, and we will discuss about that in detail as well. We already covered how light source provides beam, which is measured in luminous flux, and this beam is reflected on an object, which we call illuminance, and it's measured in lux, and the eye that absorbs the light called luminance. However, we need to understand the scope first. What is the purpose of this lighting analysis? Why are we creating this light? Why are we doing this kind of analysis to provide this ambient and everything? What is the function? How many people will use it? There are loads of details go into it before we start doing the analysis and even try to understand the analysis. The capabilities of Revit is limited on a sense. It's not a lighting software, but it can do quite a bit. One thing you can do is solar analysis, which is a cloud-based. It contains also daylight, and it contains combined daylight and artificial light as well. You can also use illuminance rendering in Revit, which can also be used in the cloud. And there's Revit plugins that help you to compute more accurate data, which connects Revit lighting the data with their lighting software and gives you more accurate results. If we look at an example of the first option, the solar analysis, here you can see that there is a daylight as well. The lower, the red is less consumable, less lighted areas. The blue is a little bit more light up areas. The green is quite light up areas, and the yellow is very bright areas. This analysis measured in lux, so you can see the scale, how it raises from 0 to 107, from 2071 all the way to 6000 lux. And this is kind of illuminance analysis in the cloud. We can also run Revit rendering with illuminance, and here we can see how the room is being light up. So in this case, the bar is measured by foot candles. In this case, we can see that there are certain areas where there's more light in yellow and less light in blue, and behind the stools, for example, or within the internal part of the shelf, you can see that it's all blue. But these generally include daylight as well. You need to make sure that you exclude those and do it solely with the artificial lighting within your rendering settings. We'll do a demonstration on those. And then you can also use Revit plugins, which will give you more accurate data, and you will be able to even measure individual points, how much lux per foot candle or meter square you can see in a particular point. Revit also allows you to generate schedules in order to get your data into schedule, and that's really important if you want to present or discuss or even include within your reports delivered to the client or manufacturers.